Previously, we created an animated texture by looking at the Unity documentation. Here, I want to continue the factory series where we'll look at bite-sized examples of visual scripting and C#. Check the chapter titles if you want to skip ahead. This is an old video I recorded and never edited, so please excuse some minor differences, like that a flow machine is now called a script machine. I'm going to do a little bit of review of the last video before we get to scripting some physics. My C# script and my visual scripting graph do the same thing. They have the same variables. I have object variables, texture speed, and conveyor force for the public variables, and the private variables in the script are graph variables in the visual scripting graphs. Since they are graph variables, we won't see them in the inspector on the game object, but we can see them in the graph. So there's a graph variable right here for our conveyor renderer. Talking through the texture moving real quick, we get the renderer component on start and save it to our variable because we're going to use it to modify the material of the conveyor belt every frame as we change the offset of the texture. On the VS graph, we get the renderer component that displays the object and we save it to a graph variable. The next private variable is a vector2 called scroll offset. We actually don't need this variable in visual scripting. Let's look at what it's doing in the script. Scroll offset is being set in update every frame, and we have our update here in the graph. And I promise I'll go faster with this stuff each video, I just want to make sure I don't lose anyone. So on update, we're saving scroll offset as a new vector2. And in the graph, I'm using human naming, so it's create vector2. The x of the vector2 is 0 for both, and for y, we're doing a calculation where we get the time in seconds that the game has been running, and we multiply that by our texture speed variable to have control over the speed. We multiply the y offset by -1 to reverse the direction of the scrolling. In C#, we're setting all this as a variable. In visual scripting, the result can just be plugged right into the set texture offset node, and it is easy to read. We could take this whole thing and pass it into the set texture offset on this line, but then the line is really long and it's hard to read. This way, we can see that the result has a name. That name makes it clear what it's doing, and we can see in the next line what it's being used for. Let's get to adding physics to the conveyor belt, because these pink balls aren't going to ship themselves. Looking at the graph first, we have on collision stay. Something hits the conveyor belt, the collider of the pink bouncy balls. And we want to add a force to the rigid body on those Unity primitive spheres. We'll use the collider to get the attached rigid body, and then once we have the rigid body, we can add a force to it to move it along. The kind of force we want is force mode acceleration. Any size or mass that an object is will move the same way across the conveyor belt. So something light won't move any faster than something heavy. We need to use the vector3 to give a force to the rigid body of whatever is on the conveyor belt. But it's best to have a speed value just be a float, one number, instead of 3 numbers that would be the same. I created a vector3 and fed the same value to each input, the x, the y, and the z. And then we multiply the forward direction, the direction we want the force to go in, by this number. Therefore, the xyz forward direction is being multiplied by the same number. We don't want to change the direction. The forward direction of the conveyor belt should be the direction the objects go in, but we want to increase or decrease the magnitude, the force of acceleration, along that direction. The C# is a little different. We take conveyor force and multiply it by 100 because time.delta time is really small. Time.delta time is the time it took the previous frame to complete. Visual scripting's per second node is similar and can be more intuitive to use, like something like a car traveling meters per second, regardless of the frame rate of the game. The reason we use these, time.delta time or per second, is so the movement is consistent and smooth across different frame rates. Next, I'm getting the transform forward, and I broke it up into its parts, which is kind of silly to do here because you can just multiply the transform.forward and not create a new vector3. But I thought it might be a little clearer what is happening here to make it look a little bit similar to the graph. All of this is then set to a new vector3 called conveyor calculated force. Conveyor calculated force is actually a new variable. This kind of variable only is accessible inside this method on collision stay, and for that reason it is called a local variable. And this is plugged into, okay, let's break the next part down. Our collider comes in from on collision stay, and then we get the rigid body from the collider, and we run add force on the rigid body. Same thing in the graph, on collision stay, get the rigid body and add force. And then in the code, we have this variable of this calculation called conveyor calculated force. Here, we don't need to do it. We can just plug it right in. Just like before, in the code, it's easier to create a variable that is the result of this calculation and pass that into the add force. And then here's that same calculation in the graph. Pressing play, the script is working, and that's why the graph isn't running. We can speed up the texture speed and change the force. These are, of course, the public variables in the script. I'll turn the script off and the script machine on, and we can adjust the same things. And the cool thing is that since the forward direction is local to the object, we can rotate the conveyor belt and shoot the bouncy balls anywhere we like. I kind of like how they're going in the factory here. Interesting. That's kind of why I like this project, because you can get one idea after the other, and it's a fun small puzzle to think of what should happen next and how to make it. Let's look at the booster ramp. The booster ramp is exactly the same thing, but there's no texture speed and the conveyor force is greater. Easy. So you can have the same graph on different things with different values for the object variable because the variable is an object scope. Next, let's do the zero gravity tube. We're doing this with triggers, so the collider needs to be marked as trigger. This is a ProBuilder object. This is a cylinder, and let me show you the whole game object stuff, because sometimes you'll want the collider and the graphic object to be different game objects. In this case, I want a tube, but the trigger should be a volume inside that tube. Okay, so I have a little cap on the end of the tube. The parent tube is the 3D model, which is a tube, and then the script is on a cylinder object where the mesh renderer is turned off. So it's the volume inside the tube. We're doing on-trigger enter this time. We're getting the attached rigid body like before. I'll do a dotted line here. Then we're saving the rigid body. Then we're setting use gravity to false on the rigid body that entered this trigger. On the set use gravity node, we have a Boolean toggle to flip for false. In the script, that's ball rigid body dot use gravity equals false. Then we want to slow the ball down, kind of like it was shot into a cube of jello or something. We're getting the rigid body we saved, we're getting the velocity of the rigid body, and then we'll divide it by a value, 333. And then we'll set that value back to the rigid body. This time we're not multiplying a vector 3, we're dividing it because we want the object to go in the same direction, but a lot less. On trigger exit, we do the same thing as the above, but we turn the gravity on. That is, we set use gravity to true on the rigid body. I could name this incoming collider to something else, like collider leaving tube, but as we've seen in the video in the graph, it is easier to read the noodles plugging in to the nodes without having these local variables. I'll press play with the script machine on, and we'll see the enter trigger fire and the exit trigger fire. Cool. A great little effect from a small graph. That's what this series is all about. With any luck, with a few more videos, we might solve the global supply chain crisis, at least as it concerns bouncy balls.